What's going on, guys? In this video we are going to see how to solve an exact differential equation. Now the standard pattern of an exact differential equation will look like this. We will have a function of m of x comma y plus n of x comma y dy by dx it's equal to 0. So this is the standard pattern. Now from this one you can look at this one and compare with this pattern and find out what is m of x comma y and n of x comma y. Here we have y prime means this is equivalent to dy by dx. So whatever the value that's multiplying it, that's our n of x comma y. This is our n of x comma y, and this is our m of x comma y. Now the next thing is we have to find out the derivative of this one with respect to y and derivative of this one with respect to x, and see whether these two are equal. If these two are equal, then only this is an exact differential equation. If it's not, this is not exact differential equation. So in that way you have to find out the integrating factor and multiply, and you have to make that one exact. If you want to know how to do that, like those kind of problems, it is in my playlist. You can go ahead and watch them. And here I'm just going to show you an exact differential equation. Now to prove this one, this is an exact, first we have to take the derivative of this m with respect to y. Now let's go ahead and do that. So m with respect to y, here we have y cos x. If I take the derivative with respect to y, we treat x as a constant. So this is going to be just cos x, because y will become 1 when we take the derivative. And here again we treat x as a constant, only take the derivative of y. E power y derivative, it's also e power y. So this is going to be just 2x e power y. Now let's go ahead and take the derivative of x with n with respect to x. If we take that, this sin x will turn into a cos x, and then x square will become 2x plus 2x e power y. And if we take the derivative of any number, that's going to be just 0. So that's 0, we don't have to write that one. Now from this one you can see these two are equal, right? These two are equal, therefore this is exact. Now after we find out this is exact, what we have to do is we have to equalize this first function m of x comma y to a function with partial derivative with respect to x. Okay, we have to do the opposite. Like when we take the derivative of this one, we have to do the derivative with respect to y. When we equate this one to a function, we have to consider this is a function of partial derivative with respect to x and equate that one to this function, that is y cos x plus 2x e power y. And we do the opposite for this one. We take this function and equate to a function of partial derivative with respect to y, and that's going to be just sin x plus x square e power y minus 1. Now this is a function with partial derivative with respect to x. Now to get this function back, what we have to do is we have to integrate this one with respect to x. If we integrate this function with respect to x, okay, wait a minute. Okay, so if we integrate this function with respect to x, we will get a function of f of x comma y. Okay, I saw the integration first. F of x, we have to take the integration with, this is partial integration with respect to x, and then in the other side we have to do the same thing, partial derivative of this whole thing with respect to x. Y cos x plus 2x e power y dx. Okay, and if I take the integration of this one with respect to x, the integration and partial derivative cancels each other, and finally we will end up with a function with x comma y. And here if we take the integration of this one with respect to x, we treat y as a constant. So this is going to be integration of cos x, that's going to be sin x. So we will get y sin x, and integration of e power y, actually 2x, because y is a constant. We are doing the integration with respect to x, so this is going to be 2x square divided by 2. 2 cancels, so we will get x square e power y. Okay, now this is a function. Now also when we do the integration with respect to x, we have to add a function with respect to y. Okay, now this is the part we have to solve finally. we cannot leave h of y as it is. We have to find out what is this value. To find this one out, what we do is, that's why this second part we need this part to compare. Like we are going to take the derivative of this one. We took it from partial derivative with respect to x to this pattern. Now we have to take the derivative of this one with respect to y and compare with this one to find out what is our h of y is. Now if we take the derivative of this one with respect to y, we treat x as a constant, so this is going to be just sin x, and here we will have, if we take the derivative with respect to y, x square will remain the same, and derivative of e power y is still e power y, and derivative of h of y, that's going to be h prime of y. Okay, now let's go ahead and compare these two, this one and this one. If you compare, you can see first one is same, sin x, second term is same, x square e power y, x square e power y. The third term, h prime of y, here we have -1. So from this one we know that h prime of y should be equivalent to -1. So now we have to solve for h of y. To find out h of y, we just have to integrate both sides with respect to y. So integrate this one with respect to y, integrate this one with respect to y, you will get h of y that is equivalent to -y, and you can add a constant if you want, because finally we are going to equate everything to a constant, so you can leave it as it is and plug it in this equation. We already found out what is our f of x comma y, that is this one. Now instead of h of y, we just have to plug this value, that's it. Now, and also we have to equate everything to a constant, so in that way we don't have to worry about adding extra constant or anything. Okay, and if you add a constant, you can equate that one to a 0. Now if here what we have to do, we equate this one to a constant, and y sin x plus x square e power y minus, instead of h of y, I put -y, and this is going to be the solution for this exact differential equation, and that's how we do that. And if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.